This is video number 4 for sections 3.1 and 3.2, the method of elimination. Elimination is the second of the algebra methods for solving systems of equations. You do need to know both methods, both substitution and elimination. Make sure on the homework that you're practicing the method that they're asking you about. Once again, I gave you a list of steps over here to follow, and we will once again demonstrate that list of steps using an example problem. Just like before, there is a preliminary step that we should take, and that is clearing the fractions. Fractions are just not helpful when solving these systems. Looking over at my problem, the second equation looks just fine, but the first equation has fractions in it. The LCD of that first equation is 3. So if I simply multiply both sides of the equation by 3, I can clear the fractions. Looks pretty simple. The left side becomes 3y, and on the right side, all that's going to happen is those 3's are going to cancel each time. And so now my first equation there no longer has fractions. All right, step 1, a little bit different start than the last time. We're not trying to get a variable by itself this time. Step 1 is I need to put the two equations into what's called standard form. Standard form means all the terms with x and y on the left and all the terms without x and y on the right. Now looking over at my two equations, it looks to me like this equation is already in standard form. X's and y's on the left, number term on the right. That one we were just working with, however, is not quite in standard form. This x term is on the wrong side, so I'll need to move that to the other side, resulting in 4x plus 3y equals negative 14. These two equations together are now in standard form. Let's go ahead and rewrite the equations so we can see them next to each other. All right, steps 2 and 3 are really the critical steps in this process. Step 3, let me jump down there, says that in just a minute we're going to add these equations together. That's what it sounds like. I'm going to draw a big bar here, and I'm going to be adding up the terms on the left and adding up the terms on the right. But as it says there in step 3, that's only going to be helpful if I can eliminate one of the variables. Now don't write this next part down. If I was to add these equations together right now, I would have 7x, I would have plus 1y, and I would have 18. That is not helpful at all. The only reason to add the two equations together is so that one of the variables disappears. Well, this is where step 2 comes in. Step 2 talks about using a multiplication trick. Here's the idea. If you take a look at the two equations that we have, right now, if I added the equations together, I'd still have both variables. Well, let's think about what I would need to change so that one of the variables would drop out. You can either change the x's or you can change the y's. In this problem, the y's look kind of appealing to me because one of them already has a minus and one of them already has a plus. In other words, boy, I wish this said negative 2 and positive 2. Or I wish this said negative 3 and positive 3, because then if I added the two equations together, the y terms will disappear. Well, I can't change a 2 easily into a 3 or a 3 into a 2, but what I can do is change each of those two numbers into a 6. Where am I getting 6? Well, 6 is the smallest number that both 2 and 3 go into evenly. Let's change those into 6's using multiplication. To do this, I'll multiply the top equation by 3. Notice that 3 times 2 there is going to make a 6. And I'll multiply the bottom equation, both sides, by 2, because again, 2 times 3 is going to make that 6. Let's carry out that multiplication. Remember, you have to multiply both sides of the equation by that number. I now have two adjusted equations, and I can see that if I want to add those equations together, now I'll have 17x. The y terms bow out. 96 minus 28 is 68. And the point is, we eliminated a variable. Now I have a simple equation, one variable, that's something I can solve. That's what step 4 says in our list, solve the resulting equation. That's actually very simple. Looks like if I just divide both sides by 17, I'll have what I need. I can go to the calculator, and what you will find is x equals 4. Now remember, that's not the final answer, that's part of the final answer. We're looking for an ordered pair, an x and a y. That's why step 5 in the list says that now we need to back substitute. This is just like the other method. I need to take that 4, I need to go back up to one of the equations earlier that had x and y. You can really choose any of the equations in our list where there's both an x and a y. So either of the original two, this one here, this one, any of these would be fine. I would just pick whatever one looks relatively easy. How about this one here, since we've got it already? I'm going to take my 4 and I'm going to fill it in for x. Let's go ahead and fill that in for x. I've simply rewritten the equation, substituting in 4 for x. Now I have a simple equation involving y that I can solve. Just carry out the simple algebra steps. And it looks like I'm ending up here with y equals -10. Step 6 on the list says don't forget to give your final answer as an ordered pair. And so for us, that would be the ordered pair 4, -10. There is once again that optional final step where you can check your answer. To do that, you would simply have to take your ordered pair, go back up to the two original equations, substitute in x and y in each case, and make sure you end up with true statements. One last comment. Looking back at this step, the step where we had to decide on the multiplication trick, we chose to eliminate the y's. We could have chosen to eliminate the x's, and hopefully you see that the number I would have changed these two into would be 12. 12 is the smallest number that 3 and 4 both go into. To be a little more specific, I would have to turn one of them into a positive 12 and one of them into a negative 12. So maybe I'd multiply the top equation by positive 4 and the bottom equation through by -3. You might want to try that on your own paper just to see that you'll end up with the same answer. If you used that approach, you'd get the y equals -10 first, and then you would substitute that back in and end up with the x equals 4 second. Either way is acceptable. And then one final comment. Suppose in our original problem this 2 was not there. In this situation, I would have only needed to use one multiplication. Just multiplying the top equation by 3 would have provided us with a situation where the y variable would disappear if we were to add the two equations together. So different things can happen. You just have to remember that the goal is to eliminate a variable